So in this problem, we're told that a ring-like wheel of radius r has a force F equals at squared applied to it tangentially. It takes a time t to make one full revolution, and we're asked what the mass of this wheel is going to be. So first, in part A, we're asked to find dimensionally how that mass is going to relate to A, R, and T. So that's what we're going to do first. So remember that the dimensions of force are mass, length per second squared. And so that tells us that the dimensions of A are going to be mass, length per time to the fourth, because it has to be multiplied by time squared in order to gain dimensions of mass. Dimensions of R are just length, and dimensions of period are just time. So this tells us that we can use one inverse factor of R to cancel out that L, and 4 factors of period to cancel out that t to the negative 4 in order to get mass is proportional to A t to the 4th over R. So that's our answer for part A. Now for part B, we're asked to find how the mass relates to these things directly as an equation. And so what we're going to do is we're just going to integrate a couple times. We know that torque is equal to R cross F. Since the radius is perpendicular to the force, the two are the force is tangential. This tells us that torque is equal to R times A t squared is equal to, of course, I alpha. So then alpha equals d squared theta dt squared is equal to RA over I times t squared. So this allows us to take our first integral, the integral from 0 to omega at time t of alpha dt is equal to the integral from 0 to t of RA over I t squared. So then omega of t is equal to RA over 3I t cubed. Then, of course, we can take immediately another integral, the integral from 0 to 2 pi. So one full rotation of omega dt. This is going to be the same as the integral from 0 to big T, the period, of R over 3I t cubed. And we can do this because we know that the wheel makes one full 2 pi radian rotation in a time t. So this tells us that 2 pi is equal to RA over 12I t to the 4th. We know that since it's a ring, we have that I equals mr squared. So we can plug that in. That gives us that 2 pi is equal to A t to the 4th over 12 mr. And this tells us that m is equal to A t to the 4th over 24 pi r. And so the constant coefficient for mass is going to be 1 over 24 pi, and then multiplied by this formula that we derived based solely on the dimensions.